relations and functions. First thing you have to remember, if we're going to be graphing, we have our Cartesian plane. The Cartesian plane is the 4-grid square you see here. The first quadrant is our problem-solving quadrant. This is one of our most important quadrants we deal with all the time. That's our problem-solving quadrant. Then we deal with other quadrants. Okay, I'm just going to highlight your problem-solving quadrant. He is one of the most important quadrants we deal with. Then we go counterclockwise. This is quadrant 2. We normally use Roman numerals to label them, but if you go 1, 2, 3, 4, that's okay as well. So this would be quadrant 3, Roman numeral 3. This would be quadrant 4, Roman numeral IV. Okay, that's how we would name them. Now your quadrants is like a map. In order to locate something, you're going to have either a longitude or latitude on the map. Longitude and latitude are a big way of saying left and right or up and down. That's all it is. Left, right, up, down. It's all on a map. Okay? Latitude is going left and right. Longitude, long is up and down. Same as the Y is up and down. So these guys are all positive numbers. Okay? We deal with X and Y. So for example, this line right here is called our x-axis. Okay? That's our x-axis. I'm sure you remember from last year. Okay? And the vertical one is called which? The y-axis. You're right. Yeah. This guy here is called our y-axis. All right. What is it called right in the middle? What is this 0 point called? The origin. Good. Okay, that's where everything originates. That's where we start. It's known as your starting point. Okay, the origin has a point. All of these locations have a point because we have two axes. We have an X and a Y. So to locate a point on a map, you need to have an X, comma, Y coordinate. It's called a coordinate. Okay? Where will we find in real life that uses coordinates? What would use a coordinate? Maps, yeah. What else? So what kinds of jobs would use maps? Construction, what else? Think of it in the air. Airplanes, skyways. There's actually highways up in the air. They're called skyways. They need to know how to map things out so they don't crash in the air. Okay? It's a little bit more of a 3D map for them. So, yes, these are coordinate planes. We need to locate things. Now, what we're going to do is we're going to look diagonal. Diagonal from our positive is going to be quadrant 3. It's exactly negative. It's the opposite. So, this one is our negative quadrant. Now, if we go above, and since we always have X first, then Y, if we go above quadrant 3 into quadrant 2, we're going to have X, if you notice, X going left. Well, if he's going left of 0, if my head is 0 and he's going left of 0, he's going to be in what kind of numbers? Negative numbers. So X is negative over here, but if you look at the Y's, we're still going up. So we're still positive going up for Y. Okay? Now we can take off and go diagonal from him, quadrant 2 down to quadrant 4, and these guys are going to be the opposite. So instead of putting negative first, we're going to flip-flop the negative and positive. So we're going to go positive, negative. I didn't have quite enough room to write that there. The next page deals with the page we're dealing in front of us, which is this graph grid. It's got questions about the graph grid. So to answer the questions, I'll have this slide up, but please in your notes, always go back to this graph, okay? All right, let's take a look at those graph pages. The first one's saying, complete the following coordinates of the points represented by the letters on the grid. So we have letters A, B, C, D, and letter O. So if we take a look at the graph, we want A, B, C, D, and O. So I'm just going to highlight those real quick. So there's A, there's B, there's O, and C is way over here. Okay, so those 4 points. Give it a try. Give it a try on your own. Try and label them. Remember, the X number goes first, the Y number goes second. Okay, I'll give you a minute for getting those down. Push pause now, play when you're ready. Okay, let's see how far you got. So, A, we should find A is 2, 4. We always start at 0, 0 right in the middle. Go right 2, up 4, okay? So, what about letter B? Letter B didn't go up or down, we just went left. So how would we write that as a coordinate point for point B? How would you write point B? Okay, well, X goes first. He went left. How far left did he go? 3. So -3. The negative tells us he went left. But he didn't go up or down, did he? So we put 0 there. Okay, he didn't go up or down. All right, let's take a look at letter C again. Letter C is way over here on the right-hand side. So if we talk left and right first, he went right how far? 6, and down how far? 3, good. So we're going to have he went right 6 and down 3. Remember, down means he goes negative. That's what that negative sign means. Okay? Let's take a look at the next question. D and O. So if I look at D, D's on the line. He didn't go left to right. If he didn't go left to right, what do I write? 0. How far down did he go? -3. So this guy's going to be 0, -3. Put some slashes on 0 so you don't think they're O's. Now, what is that O sitting there for? Point O. If we look at point O, what is point O?
Origin.
The origin. That's why they've named it point O. O for origin. Okay, that's where we start everything. We already discussed origin is 0, 0. So back over to our page, you'd say O is at 0, 0. Okay? Then it says B, write the coordinates of the second quadrant. And then C says write the ones in the third quadrant. So let's take a look at the second and third quadrants. So that means if I take my green highlighter, in the second quadrant, I've only got one number sitting in there. That's my point E. So where is point E located? How far left did he go? 2 left, and how far up? 3. Good. So -2, 3. So this guy's at -2, 3. And what letter does he have? What point is he? Letter E. Okay, that was location for letter E. Now let's look in for quadrant 3. What is the only one sitting in quadrant 3? Letter F. Good. This guy's sitting in quadrant 3. So how far left does he go? 4. How far down does he go? 3. Good. So this guy's going to be -4, 3, and -3, pardon me, because he went left and he went down. So if they just said to you, describe what that point means, you describe the point exactly like that. The X letter you describe as a left or a right movement. The right letter, the Y letter, you describe as an up or down movement. Okay, positive's up, negative is down. All right, let's take a look at letter D here. This is where we just wrote our quadrants as well. So they're just asking us about these, okay, what we wrote here, what each quadrant is. So they just want us to write it down in our chart. So here's our chart. For quadrant 1, this is our problem-solving quadrant. Okay, this is our problem-solving quadrant, where everything is always positive. Quadrant 2, X goes negative, Y still positive. Here, let's write my positives in green, negatives in red. How about that? There you go. Now, quadrant 3, what do we know about that one? Both negative. They're opposite than quadrant 1. These two, as we said before, are opposites. And same as 2 and 4. They are also opposites. All right, so if I know 2 is negative positive, that means the Y number is going to be negative here, and the X number is going to be positive. Okay, these two are opposites. All right, moving on here. I want you to read this page. This one's trying to tell you about how we graph equations from tables of values. So give that a read, and we're going to go through it. Now we have our toothpick example here. So it says we have 3 toothpicks that are used to form a triangle. A second triangle is formed by adding 2 more toothpicks. So here's our original triangle. The original triangle. And what they're showing us is that to make a second triangle, they're only adding 2 separate toothpicks. So they added those 2 separate toothpicks to make 2 triangles, and they added 2 more to make a third. Okay? So it wants to know how many toothpicks would be in each of these. So we would call this number of triangles. That's 1 triangle. Here's 2 triangles. Here's 3 triangles. So in 2 triangles, how many sticks did I use? The original 3 plus how many? 5, exactly. Okay, and over here, how many green did I have to add? 2 more. So what's 5 plus 2? 7, good. So what do you notice the pattern's doing? They're going up by 2, they're adding 2. Now what you just read says, you take the pattern from the Y list. How do I know that's the Y list? There's a reason. Do you remember why? No. Y's can also be negative. Let's try though. What do you think? Why is he Y? Because X goes first. And right here, if it's set up as a table here, X is first, then Y. Always, always. So we have 2 different types of tables of values. This is called a horizontal table. Where the numbers are vertical. These numbers that match are actually vertical. So that is a coordinate point. That is coordinate point 1, 3. Okay? Then we also have vertical tables of values. Normally we see vertical tables. A vertical table would be like this, where you have X over here on the left and Y. Now again, we do most of our questions in problem solving. So what they're going to do is they're going to change that X and Y to the variables that match the situation. If it was cost and time, we would have T for time, C for cost. Okay? And they would change them according to the situation. All right. We're continuing our pattern. We're adding 2. So what comes after our 7 here? 9. Then what? 11. Good. So the rule it told us is find the pattern in the Y's. It's going up by 2. And divide it in the pattern of the X's. Well, what's X going up by? They're just going up by 1. So does 2 divided by 1 change the answer? No, it's still 2. But we're essentially doing that. We're going 2 divided by 1. That's the pattern. So here's my answer. I get a final 2. That number goes in front of the X variable always. That's what you read. That's what it told us to do. That's the rule. So this 2 is going to go sit in front of this guy. So it's going to be a 2t. Now what we have to do is we pick a test point. Okay? So we're writing our equation. All right, we're on letter F here. We're writing the equation. We're actually doing letter F first. So to write the equation, we found this. We know that we've got this part. I'm going to write letter F right here just so I have room so you guys can see it. So I've got 2 times my t's. Now I put a blank. I have to add or subtract a number to get to my y numbers, which are my p numbers. Okay? That's our generic equation. And we have to find out what belongs on that blank to finish our equation. The only way we can figure out what's on that blank to finish our equation is by choosing a test point. So, you usually choose the first point, but it doesn't really matter. So I'm going to choose that first point just so it's easier for us. And here's my test point. Okay, I'm using 1 and 3. What do I do with my test point? I substitute it for x and y. Then solve for the unknown number. So, I do exactly that. So just again, I don't have enough room, I write really big, I'm just going to write right here. I'll erase it in a moment. I'm going to have 2 times my t number, which is x, because x equals t, over here. So 2 times my x, like I said, is t, plus something, or subtract something, is going to be equal to my p number. All right, the numbers I chose are 1 and 3. Now you do the bed mass. You take these numbers, they're sitting side by side, that means multiply. What's 2 times 1? 2. How do you get from 2 to 3? You add 1. So I put a 1 there, I cross out my subtract sign. I don't need the subtract sign. I know that now that I'm adding. So I cross out my subtract sign there in my generic equation, and now I put a 1 there. So now my equation is 2 times my toothpicks plus 1 gives me my P, number of toothpicks. I'm sorry, T for triangles. So 2 times my number of triangles plus 1 gives me my number of toothpicks, P for toothpicks. Okay? That's what that's describing to us. All right. Now we're going to go graph that in a moment. So letter D says, explain why it would not make sense to join the points if we were to draw this grid. We're going to draw it right away, but why wouldn't we? It's telling us it doesn't make sense to join the points, but why wouldn't I? Are they saying you can use any type of toothpick, cut it in half, chop it in 3/4? No. So you can only use full, complete toothpicks. You can't cut them in half. You can't take part of one, which means because you can't take part of one, you're not going to join the dots in between. If you join the dots, that means there's data values in between them. And here, there's no data values in between them. We can't have a 0.5 of a stick. Okay? So let's plot our points now. All right, we're going to plot every single one of these points. Let me just erase some stuff up here for you so you have room. All right. So I'll put my equation down that we found. 2 toothpicks plus 1 gives me, 2 triangles equals my toothpicks. All right. Plotting our points. There's my 0, 0. I do exactly what this tells me. I'm going to go 1 right, 3 up. 1 right, 3 up, I make my first point. The next point, 2 and 5. So you're now going to go to 2 and go to question, or go to 5. Okay, because that's 3. This will be 5. This will be 7. This will be 9. Okay, so 3 we go up to 7. 4 we go up to 9. 5 we're going to go up to 11. And again, remember, I'm not joining the points. I'm not going to join those points. Okay? So, if you ever want to say because for an answer, we use this abbreviation, B/C. That means because.
Why can't we just write because?
If you want to, go for it, but I find it long. I write the short words if I can. Just to save space, so I have less space up here to write, that's all. So, why does it not make sense? Because we can't take part of a toothpick. Only whole toothpicks. That's what's going on. You cannot take parts of it, you can only have whole pieces. All right. Any questions about this graph? We have 2 more questions they're going to ask about us. The questions are on the next page, or at the, yeah, they're on the top of the next page. These questions say, G, use our equation to determine the number of toothpicks if there's this many triangles. So again, here's our equation. Toothpicks is equal to 2 times my triangles plusing 1. That was the equation we got last time. So now we're going to actually put in the numbers they tell us. It says, find toothpicks. So I'm looking for P. I still don't know P. If I've got 27 triangles though. So that number I'm going to put where the T is. So I've got 2 times 27 plus the 1, and that's going to give us our number of toothpicks that we need. All right, 2 times 27, 54. We got to add 1, so we need 55 toothpicks in order to make 27 triangles. Okay, that's what that tells us. We need 55 toothpicks. To make 27 triangles. That's what that told us. This next equation does it a little bit reversed. It tells us we have this many toothpicks. So I know I've got 83. That's my toothpicks. I use my equation, 2 times the number of triangles, plusing 1. All right, you solve your equation exactly as you would solve a normal equation. We need to get rid of this positive 1 because we want our t by itself. So how do I make a positive 1 go across an equal sign? You subtract it, you do the opposite. Okay, so you do the opposite operation, subtract 1, subtract 1. 82 equals 2 triangles. Now what do I have to do? Very last step, what would you say? Yes, divide by the guy in front of the variable, okay? Now why are we dividing? Because they're sitting side by side, meaning multiplying. You're doing the opposite function. So you've got to do it to both sides. So you're going to say t is 41. You have 41 triangles you could draw. We're going to discuss the difference between continuous and discrete variables. We noticed in our last example between p and t, we only had limited values. We could not take half of a triangle or half of our toothpicks. We couldn't take half of our toothpicks. That means it's called a discrete variable. Okay? Since it's a discrete variable, it becomes a discrete type of situation. So discrete versus continuing. So discrete means you do not join the points. Okay? The only ones you would ever join points on are the continuous ones. So ones like your age. Do we age every day? Absolutely. Do we age every hour? Absolutely. Do we age every minute? Do we age every second? You bet. So because there's data values in between every hour, every day, that means it is a continuous variable. Same with growing and height. Okay, it's a continuous variable. Now look at these bottom ones. We have 4 examples. 100-meter sprint and comparing it to time. Now, when we think about track meets and when they're doing sprinting, what do you know about that? Do they go sprinting? Oh, it's only to the nearest minute? What do they do? 10th or 100th of a second even, okay? So that's very small data values in between large ones, which means this has to be what kind of variable? Continuous. You would join the points there. What about your shoe size? Can you buy a 6.75 shoe size? Can you buy 8.9 shoe size? No. They're only in exact sizes or half sizes, that's it. And if you're in European sizes, they don't even do half sizes. Okay? So this is considered to be a discrete variable. Okay, you would not join the points there. Number of students who pass Math 10C. All right. Can I have 5.2 kids pass? No, I can only have whole people passing. I can't chop you guys in half. I can't rip your arm off and say, okay, this part of the kid passed. There's no way I can do that. All right? Only your arm can't pass the course. All of you has to pass the course. So that would be considered a discrete variable. Now, what would height of students in growing be? Can you have a 5.32 meter person or a 5.3 inch person? Yeah, you can have any size of person according to what they give you. So this would be a continuous variable. There's data values in between. Any confusion on lesson 1? Okay, this concludes lesson 1.